Introduction to LV Statcoms. This video provides an introduction to the low voltage Statcoms. It explains what they are and how they work, why we're using them, and where on our network they are best suited. What are they and how do they work? The word Statcom is a combination of static synchronous compensator. Statcoms are power electronic devices similar to standard solar PV inverters. But rather than injecting real power from PV systems, they inject or draw reactive power to keep local network voltages within statutory voltage regulation limits. They do this by emulating a shunt inductor or capacitor. A detailed explanation of how reactive power can regulate voltage is included at the end of this video. Why are we using them? With the transition to two-way power flows from rooftop solar PV installations, regulating voltage on our low voltage network is a growing challenge. We are using LV Statcoms to help balance phase voltages and improve power quality at the edges of our network. They're a cost-effective and quick solution when compared with the traditional augmentation options, and if they are no longer required, they can be redeployed elsewhere. Where on our network are Statcoms best suited? Statcoms are designed to be installed on semi-rural and urban overhead low voltage networks that are experiencing issues with sustained and short voltage fluctuations. Each site is assessed on a case-by-case basis, so if there's an area where you think a Statcom may be able to resolve an issue, talk to your region's asset management team. This concludes the basic introduction to LV Statcoms. More information, including links to other videos in this series, is available on this page and on the LV Statcom Deployment SharePoint site. How reactive power regulates voltage. Reactive power can be used to regulate voltage by manipulating power flows and line losses on the grid. Take a simple power network supplying a customer load. The voltage at the customer is the supply voltage minus the load current multiplied by the line resistance and line reactance. The voltage at the customer load is lower than the supplied voltage because of line losses. From Ohm's law, we know that voltage drop equals current times resistance. Because the line impedance is made up of resistance and reactance, the customer voltage is at a slightly different angle to the supply voltage. The important thing to note is that the customer voltage is smaller than the supply voltage. Now looking at the impact that the Statcom has on network voltage. To boost customer voltage, the Statcoms inject reactive power like a shunt capacitor. This reactive power changes the current that flows through the line and as a result, the line losses. In this example, the line current changes and so does the resultant voltage drop. You can see from the vector diagram that while the voltage at the customer load is still smaller than the supply end, it's higher with the LV Statcom installed. As a result, the Statcom has boosted or raised the customer volts. To reduce or buck the customer voltage, the Statcom draws reactive power from the grid, like a shunt inductor. This has the reverse effect shown previously. You can see in the vector diagram that the customer voltage is now lower than in the starting example. At first, this may seem like a bad thing. We're making the voltage at the customer worse than it was. The important point to note here is that the Statcom uses this mode of operation during reverse power flow. Under this condition, the customer voltage is higher than the supply voltage, potentially causing overvoltage issues. The Statcom adds reactive load to the network to ensure the voltage doesn't go above our legal limits and to ensure better voltage at the customer premises. This concludes the detailed explanation of how Statcoms regulate network voltage.